Good evening, ladies and gentlemen. Thank you very much for your attendance today to my speech. Thank you to the organization to let me have the opportunity to be here. Thank you very much to you to help these people to hear me better. My topic, the topic we decided to propose, they gently accept, is regarding molten salt system, molten salt heat tracing system. Okay. This is pretty much the scheme I will follow, the scheme in which I try to focus all the ideas we have regarding this system, trying to fit it in a 25 minutes speech. Okay, I'll try to do my best, and we will be a little bit of time in the introduction. For me, it's quite important to people who listen to this to know where this concern comes from, so how me and people around me get to this, how we get to these problems and these concerns, and why we think it could have been repeated, happened before, and it could happen later, and trying to understand the context. I hope it will be easier for you to understand and to detect if it's of interest to you. So, hoping that I will not bore too much, I go on. Okay. My context and my colleagues' context, we are an EPC architect engineering. Well, we do more things, but in the context we are here, this is the important role of guiding power plants and coming with a long history in power plants and having in the team people with experience in CSPs, how to detect along the project and not at the beginning the importance of one system. And I invented this figure, try to say it. I'm not very, very proud of it. I will try to improve it if I come back again. But the main idea is, and this does not happen normally, unless you are in a very not so mature environment. We did not have an actual good idea of the importance of the system at the beginning. Okay, that was our problem. We will solve it, and result will be okay. We think so, but we wonder why we did not, because there was not the first project. We have colleagues doing others. We have our clients that have made a lot, and we investigate, and it seems that it happens. And we've been near of the beginning of other projects, and we detect that it looks that it's going to happen again. And here I will try to get the concern and to get to why probably this is happening, to concern people relating with this, to keep this in mind whenever you are developing a project that is much more important than whoever could think at the beginning of a project. Okay. If we were talking about a heat tracing system or a conventional plant, the level of importance would be very, very, very low, even compared with the beginning level. Okay. So it's not that all the people think that it was a conventional system. No, we knew. A lot of people have told us, we have informed, we have compared, and we knew it was a difficult system to handle. We are detail engineering people, so when we talk about this, we know that we need to do a lot of integration and a lot of job. We knew it was harder than any other heat tracing system. However, it was much, much harder. And when we were realizing, we did realize that we could get late for some actions, but it could be conditioned. Okay, we will go later to this. So, yeah. Okay, so let's go to the matter. This is a question that you might have wondered. A big boss in my company did make the same question. So is this so important to go there and talk about it? Well, that's, probably you have your own opinion about this, but I will not say it's the most important. Okay, of course it's not. You are now trying to know how much the project will cost and if the tariff is going to be worth it. Okay, this does not affect that. Okay, not at all. So it's normal. Right now we are not thinking about this, but there are other equipments that do not have importance in this phase. Anyway, you are talking with pump manufacturers, turbine manufacturers, because it's part of the process. Okay, so it's not so important as the receiver, the heliostat, even a conventional equipment as the turbine generator. Of course, not in terms of budgetary, of course, but well, there are other important equipments that might have, in my opinion, similar importance of the molten salt pumps. But here, probably, if we talk with molten salt pumps manufacturer or mechanical engineering, we will discuss about this and we won't agree. Okay, so that's an opinion, but for sure the heat tracing system is much more important than a lot of secondary equipments of the power plant, of the BOP, of the conventional part. Okay, equipment that, yes, they do have been paid attention in the process and have been addressed correctly and has been scheduled properly and budgeted properly. Okay, so why does the heat tracing don't get the same attention of equipment that are less important than it? Well, I would say that it has a marketing problem. So if there is any manager here, maybe they can get money working for heat tracing. Okay, before I continue, I would like to say that I'm not a heat tracing system supplier. My main background is electrical engineering, so heat tracing is fits with electricity, but it's the only relation I got. It is heating pipes, so many people think it's a mechanical issue, and so on. So why I get so concerned in this compared with my normal system? Well, we will figure it out there, but I wanted you to know that I'm not selling heat tracing system. It's just the experience we get, and we are now addressing much more effort to heat tracing system design and coordination compared what we considered at the beginning, and that only happened because all our design structure did get to the idea that it was undervaluated from the beginning and it needs more attention. Okay, so as we said, in a budgetary point of view, it's not so important if you change it, okay? Compared with the big equipment, the red receiver, the yellow heliostat, and the green the turbine generator set, okay, not so important. You are not going to miss you're not going to lose a project, consider it or not consider it or whatever. If we take it apart from the main equipment, so we do not consider the receiver, the heliostat field, or the turbine generator set, the heat tracing, it does appear in a budgetary, and this is based in real cost of the heat tracing system in some previous experience and feedback we get. It has, compared with others, quite an importance. If we keep on focusing in the conventional part, that will be this graphic at the left, it has quite an impact. So why does it not get the same attention as a DCS might have in a budgetary context. We'll keep on going on that, but it does have no attention on the budgetary phase, and at DCS it does. Here I'm showing the heat tracing beside to the conventional BOP equipment. So there is not the receiver, the solar field. I also took out the turbine generator, but there's not there molten salt pumps, not cold or hot molten salt tanks. So strictly focusing in the conventional part, why heat tracing is there. Heat tracing should not be there because it's a system totally related with the molten salt. Of course, a plant will have an antifreeze molten salt system, an antifreeze water system for the steam cycle, depending on the weather condition of the plant. But that is conventional. The heat tracing we are talking about is not conventional. It is here addressed because I believe that developers, or at least EPC bidders, when they are trying to get a price and address the problem to give a price to an owner, they send the heat tracing system, they treat it as a conventional, and they have pretty much experience handling conventional equipment. So they treat it as a conventional, and that's the problem, that at the end, people used to work with conventional equipment have budget non-conventional equipment. And from there is what we think is the problem of the evaluation of the heat tracing system, that at the end cost extra efforts and probably could cost money. Okay, we'll get to the picture at the end. If it were me, this is the last figure, the right at the bottom one. If it were me, considering the importance as an engineer who is constantly integrating system and making the interfacing, I will address the importance of the different equipments like that. In that figure, the heat tracing system has a lot of interfacing and coordination issues, and is compared from the perspective of an architect engineering, is compared to the bin equipment. Okay, the number of interfacing points is quite big, and the multidisciplinary issues, as we'll see later, are big. Okay. This last one, the slide regarding the importance. Budgetary, if we put this equipment together, they cost less than a heat tracing system for a molten salt. Okay. Why do I make this allegation? When I told you we did this experience with an owner to prepare a set of technical documents to complete an owner technical specification. Okay, big guys get together, and as always, it needed to be done in a short time, and they address the lines to focus. Okay, I want this description, I want 3 PNEDs of this system, I want this and this and this and this specification. Okay, all these specifications were asked. Okay, heat tracing system were not. I wanted to use this example as when does the beginning of the undervaluation of the molten salt system begins. Also, in owners that are critical molten salt system developers, when they are in a hurry and they want somebody to do something to push forward, the heat tracing system still stays out of the equation. Okay, even though if you do research, talking with people that have been done this, you will realize that the price is higher than many other equipments that you are focusing in. Okay. So to get a dimension of the problem, we have a lot of piping to trace. Okay, that figure is extracted from a 3D model of a plant. We took out whatever is not related with molten salt to make it easier. Okay, and we only see the molten core side of the plant. The tanks and the tower and that structure will be, I asked to be removed the walls to let you see a little bit, to let you see the piping inside. Okay, that will be the molten salt steam generator building. We accumulate easily 4,000 meters of piping of very different sizes. All of that gonna be heat trace, as long as a lot of pumps, hundreds of valves, heat exchangers, instrumentation, the drainage tank that is down there, even the supports of the supporting of the pipe system, molten salt pipe system, must be heat traced in certain points due to stress issues of different for all the range of temperatures. The pipes are gonna work, and sometimes stress analysis design engineers, they detect that some supports they need to warm up together with the pipe. So it's a big issue that, as you see, is not only an electrical issue, not only a piping engineering issue, at least from now. We need to chop all this, not exactly us, but whoever takes care of the detail, it needs to chop all this big problem to place heating elements. A pipe, you could heat a big trench of pipe just in one piece, but a pump probably will need several, not only because it could be so big, also because sometimes it needs different heat transfer in different zones, depending on many factors, because temperatures of the heat trace will be very high. If they are applied to some specific areas of our equipment, it could burn up something. For example, in a bonnet of a valve, you need different heat tracing solution or heat trace heat transfer rates, because you could burn out the gland. So it's a big problem with very particular tailor-made design, and every tailor-made design area will have probably many heating elements. We're talking about hundreds of circuits and probably thousands of heating elements. Okay, anyway, somebody can say that, okay, so it's much more important in terms of money than a heat tracing of a conventional plant. But okay, so it's just a huge salt antifreeze system. Still, the answer is no. It's no. Okay, let's try to. Okay, we'll go fast in this because there's a lot of information here. Probably we cannot get into, but those are challenges that are relating the heat tracing with technological issues that right now in this position we could consider is part of a purchasing of the details of a vendor. But here are some as the business production model and the process pressure scenario. We've been in the situation to try to advance with this system and to try to confirm the power estimation regarding the heat tracing system that could get to 3 megawatts for the molten salt pipe and 2 or another extra megawatts for the receiver. We will try to go deeper in the detail now. In the moment we had our previous piping design, we could not not because it's not the way to get there, because you need to know a lot of the business production model to know how will you operate the heat tracing system. And I keep that idea, and we come here because the key point is that the molten salt heat tracing system is much more a process-related system than a investment protection system. A conventional heat tracing system would be a protection investment system that, in the case you need it to be start up because of this weather condition, wherever you are stuck and it's a very cold day, it automatically starts and it doesn't let the pipe to get inside freeze and then allows you to start later at the same as fast as you are designed. Okay, that's an investment protection issue. Here is different. Probably most of you do know that in a tower molten salt system, in a tower molten salt CSP, when the sun is gone, you do not leave the salt filling the pipes, you do drain all the salts to the tanks. Okay, that's done every night. And every morning, salts will go again up, pushed by, pumped by cold salt pumps. But they will not do that until the piping system is preconditioned. The molten salt heat tracing system is a conditioning system of the molten salt piping. So its real importance is regarding with this. It's going to work every morning. More or less it's going to work every night and every morning, because it will need some hours to get to the appropriate temperature all the pipes. Whenever the molten salt will be pumped on the pipes, they need to go through pipes with the adequate appropriate temperature, a temperature quite close of the temperature of the salt. That's it could be 288, but that will be something that the receiver supplier probably will define. But the temperature profile of the piping would need to be at certain level, and unless you have get it, you don't start up the plant. So it's a system that is working every day, and if it doesn't work, you are not starting. So that makes the huge difference with a conventional heat tracing system. So I have proposed in my company to change the name, to not letting people consider it with a wrong association with the conventional heat tracing system. I did not get right. It's still named the same. They say that you can name it differently here, but every other partner will name it the same. But we're trying to address very different both systems and trying to concern people, at least inside us, and that's why this topic was born. Try to send this message at least to owners to take measures. Okay, so they are using it every day, every morning. If it doesn't work well, you don't start up. It's massive. And another issue that owners normally take care at the end. These plants, probably you know, more research and development facilities than power plant itself. I mean, we've been seeing a lot of people saying that we've done it a lot of times, we have been making these things a lot of years, but there's not much designs, complete designs, and I'm not talking about just one piece of equipment, there's not a complete design that have been repeated many times. Probably you will be in China the ones that could be repeating some successful experience. But in the world still, sometimes when they get to a second chance, they make a change, or they change to the technology, or they change. Something important has always changed from one project to another. And what we have detected, we have been told from owners that when they are making the startup of the plant, they need to have total control on set points of the heat tracing system, because they detect that they will like to increase 1 degree in this piping because wherever, and they are constantly, and they have finished it. In Tonopah, for example, they have finished the startup, and they still would like to have complete monitoring of the issue, to make the engineers to study the issue, to make, and has a lot of consumption the system, and if they handle it differently, maybe they can save some money in the operational maintenance. They maybe can smoother the heat tracing. They are constantly focusing the system because they are constantly using it, and they are still changing temperature. They constantly, not much. I mean, it does not change the design, but they are making 1 degree up or down in this part or whatever. So it's kind of a live system that owners do know at the end that is very important, but we think they do not transmit this importance at the beginning. Okay, in our perspective of architect engineering, it's related with a lot of things, and we cannot walk linearly in the project with the heat tracing system. We need to constantly go, at least now, if we have made 3 similar, probably we will be able, and you will in the future, to have everything so clear and everything so specified in different areas, to go all at the same time, not needing to putting together isolation suppliers with heat tracing supplier, supporting big support suppliers that are very special, particular for heat tracing, talking together with heat tracing supplier because they need holes in the supports for the heat tracing to go through, but they cannot make the hole too big, because if it's too big, then it gets air, and everyone wants the heat tracing to be completely defined at the very beginning of the project, but it's not scheduled like that. And when you get to the heat tracing suppliers, they tell you that if you want a good budget from their side, and you want them to begin to work in a month's time, 2 months' time, they do need construction isometrics. I work in an engineering company, and the construction isometric drawings are quite the last of the documents that we develop, because our final product of a lot of work, and when we got it, is to send it to site to begin the piping erection. So we have someone that is heat tracing suppliers that are reminding us that as this is a tailor-made solution, you need to look at the isometric, decide how you chop it in terms of heat tracing, where to locate the junction boxes, where does the other begin to analyze the section, the isolation, and they do not want to do that with a preliminary isometric, because if they begin to manufacture, it will not fit, because again, this is a tailor-made. Every heat tracing element will have a tag saying in which pipe exactly position it will be located, and you can change some of them that could be similar, but not everyone fits in the position of the other. Okay, so we have a little bit mix up of everything with the heat tracing that maybe someone might say that it happens with any equipment of the plant, but really no. To us, it happens with heat tracing. We are pretty sure that we can work quite straight in with most of the equipment and most of the system, even very complex one, and with the heat tracing system we have stamped with the wall several times and walk around several times, okay? This is how I see that this problem begins. I think it's a matter of the owner side. We think they are the ones that are most interested in that this is a good system. And as it's not a very, very expensive system compared with the total budget, is the kind of system that is cost effective. If you focus on it and you request really what you need and a good quality, and you force it from the beginning to the EPC contractor, they will get the idea that you need something that is not conventional. Probably they will have the chance to budget it properly, and that will make everything easy. Right now, in our experience, the owner has not paid much attention they are doing, because it's a constant cycle, but in the way people that are making CSP, they get out of the business and some of their knowledge get lost. Right now, I've seen repeat this pattern, and I think it might happen again. And if I get someone to get this concern, it's nothing to do right now, it's something to do in the appropriate moment, to put some seeds at the beginning of the project that will grow later. And the main interested is the owner. Okay? So you don't do much more here in the OTS because you think that, well, it has not very impact in the budget. I don't know exactly what to say because it's a very complex system to specify. Sometimes they get wrong and they say something very specific. And if you're an owner and you make a technical specification and you say something very specific, maybe you will be the responsible of the final product. Normally, owners, although they have a very mature scenario, they do not like to be very specific to EPC contractors because then you are not letting them to improve the price and to bring to you a commercial solution. Okay, so normally you leave it a lot of things open. In this system, I won't do it. I will do that in most of conventional part, even in part of the non-conventional part, but in heat tracing system I will pay much more attention. Not saying exactly what to do, but what do you want from the heat tracing system. What would happen if you don't? The EPC contractor will not have a clear idea of what you want. Maybe they will undervalue it. Okay, that's an EPC contractor problem. Everyone has their own problems, and you have to solve them. An EPC contractor will develop an operating heat tracing system, even though it is well specified or not. Why? Because they're professionals. I mean, and because a process engineering will tell you that without it, it doesn't work. And at the end, it will be there and it will be operative. But what if you have made a budgetary approach to the issue and you have undervalued the heat tracing? The project will begin later, and EPC contractors normally, in my experience, they do have this procurement department that will take care of budgets. And sometimes a budget is wrong, and the EPC has to assume it, and there are ways to address that. Okay, but whenever they get, they sense that they're getting out of the budget, they try to make it to make it the less the gap to reduce the gap. Okay, here it's quite easy that the budget could be 2 times, 3 times, 4 times under. So the temptation to try to not lose money, because these people normally take care of a part of the project as if they want just one project. Okay, right now here we are saying that okay, it will be a little bit of money compared with the, but once you are in the project, normally you handle every problem as just little project. And if you are in a situation in which your client, in this case the CPC procurement department, they are kind of losing money, they will try to go to strictly comply with owner requirements. If you are over budget, probably you can give the owner whatever they want. You can give the engineering designer whatever they recommend. If you are under the budget, you will ask people to strictly comply with owner specification. Okay? So it will work, but you are conditioning the result. Okay, what can happen with this sequence of events? For me, it's a statistical fact that we have a process-related system with a massive quantity of active components. I mean, we're not talking, the pipe is there and we need the pipe to work the plant. The pipe is passive, and the pipe is regulated under, the selection of qualities, the direction, the commissioning is controlled, but very standard procedure, very quality assurance procedures. We have standards. Heat treating system, they do not have so much standards. So you need to put on more effort on them. And the components are active, are heating elements that can get short circuit, that can get burnout. You have power system supplying. You have hundreds of solid state relay switches that are opening and closing the circuit to provide the exact power they need. You have hundreds of thermocouple circuits to do the closed loop, because you control every chop. We said we have in the system these 300 circuits, not considering the receiver, but it has another hundreds of circuits. You have a thermocouple sending the temperature to see if you are matching it and you're stopping or not. We have a lot of components. Quality on the design, on the materials, on the performance of the equipment, it will have impact on availability. It's not like when we do have 50% pumps that somebody could say, what's the statistical of 2 pumps not be operative at the same time? Somebody will bring with a number, and we will say that it's a very low number, and it means that you have very bad luck or very bad maintenance to get to that. Okay, so only very bad luck will lead you to have only 50% of pump capacity in, let's say, hot pump, cold molten pump salts, that I think is an example typical of 50% pumps. We have a heat system here that is just one system, okay? It's a lot of elements. They will have redundancy. There are redundancy in the heat element, but there is a problem with maintenance. You know this, I showed the picture before. We have pipes at a very inaccessible places, pipes that are covered with isolation, of course, but the main difficulty is that if you get, for example, 2 failures in a circuit, and you are in a situation to change one of the heating elements, you need the pipe to warm, to go to touch it. If not, it's at 200 Celsius temperature. So we know that sometimes pushed by the by the necessity of the owner or EPC contractor. Sometimes in maintenance they do have to go to work with over 200 Celsius temperature to repair heat tracing system. That's happening right now. It should not, and probably it won't happen during maintenance, because during maintenance you will have very, very regulated the way maintenance team work, and it's difficult to think. Probably there are ways, but it's difficult to think of at night shift. Get the scaffolding, take out the pipe insulation, repair some heat tracing circuits that you have been you have detected that are faulty, with the pipe at 250 will be probably the temperature you will find, let's say 1 o'clock in the morning of the night shift, and put it again before you start up the system. Well, that's another issue you gotta see when we're talking about this, and why.
Oh, it's true.
Keeping in mind the good quality, a good failure rate of this system could have quite an impact on availability in the future. And that's why we mentioned the midterm impact to the owner to this, because failures will come with the time. At the very beginning, you will have a lot of resources in the startup commissioning, and you could do many other ways. But after that, you will have a repeating failure rate, and you will predict when do you have to stop the operation to do all the maintenance job of the heat tracing. And in Spain, there are plants that they have decided to stop completely, to remove the heat tracing system and change to other manufacturer, other design, other whatever. It's something that has happened, and I think it would be interesting for you to know. Okay, I think I'm extending too much, so many people think that as heat tracing is made with cables, it's kind of a matter of take-off material issue. This is a typical, it's not the only way to do it, and it's not applicable to any of the circuits, to every of the circuits we say, but it's the most used are mineral insulated cables. And they don't look like much a cable, they look like an antenna or a thermocouple. Okay. So it's an equipment, it's not a cable, and it breaks, and it has two weldings, and it works to 200 to 100 Celsius in the spines and contracts, and it's very sensitive to quality. Oh, okay. So I think I'm gonna miss, but I'm out of time. I think my conclusion is not a conclusion, it was a list, but I think I said everything. I will please ask owners to take care to specify a little bit more what they want and establish quality, and ask EPC contractors to dedicate time in the bidding process to explain what they are thinking, maybe make a breakdown of the heat tracing system in the budget to detect if they might be undervaluating it. Because if they do, probably at the end you will not have time to even pay money to convert to what we want. Okay, so thank you very much. Sorry I extend too much.